So in example C, we just came up with this answer. We had our 5th degree polynomial divided by our 2nd degree polynomial. We got a 3rd degree polynomial as a result. What this video is going to show is how do we check to see that we actually answered correctly. So we're going to see just with numbers. If I divided with regular numbers, how would I check? If I had 100 and I divided by 25, I get 4. That means I can work backwards and I can say 4 times 25 should equal 100. Well, I can do that with the same polynomial. I can say that if I multiply these two, then my result should be this 5th degree polynomial. So that's what we're going to do right now. So when I multiply our 3rd degree by our 2nd degree, I could use distributive property. I'm just going to go ahead and multiply by using the box method. So we're going to go ahead and fill in each of these boxes just by multiplication. So 2 times x to the 3rd times x squared is just 2x to the 5th. I'm going to go ahead and fill in the rest of those boxes right now. When I fill those in, you can see the result. Next step, I'm going to combine like terms. I don't have anything to combine with this 5th degree, so I just have 2x to the 5th. Then I would normally look for 4th degree. Don't see any, so now I'm going to look for 3rd degree. Here they are. Put those together, I'm going to have a negative 1x cubed. Next I would look for my 2nd degree. It's right here. My 1st degree, right here. And then my 0 degree, or my constant, which is right here. Let's compare that to what we started with. If I take a look at this guy right here and I compare it to that polynomial, I can see they are exactly the same, which tells me, hey, that means the answer that I got to my division was right. That means that this answer right here is the correct answer. All right. But now what happens if I have a remainder? How do I work with a remainder? So let's take a look back at example B, and we're going to see how we deal with a remainder in those cases. Okay, so in example B, I had x cubed minus 9 divided by x plus 3, and this was our answer. It had that remainder in it. So I need to know, well, was this right? So we are going to take the non-remainder portion of our answer. We're going to multiply it by the denominator portion of our answer, or what we were dividing by. I'm going to multiply those two, and we're going to see what happens with that. So now you see the result of the multiplication. I still need to combine my like terms. I'm going to start with my 3rd power because that's the biggest degree. I don't have anything to combine that with, so we're just going to go ahead and write x to the 3rd power. 2nd degree is what I look at next. So my 2nd degrees happen to be on the diagonal. When I add those together, they cancel. I then go to my 1st degree. They're on the diagonal again. When I add those together, they're opposites. They cancel. That leaves me with this constant of 27. I put plus 27. Now you're going to notice this answer does not match what we started with. That's because we haven't done anything with this remainder yet. So that we had a remainder that was minus 36. So I'm going to subtract 36 from this answer right here. That's going to give me x to the 3rd minus 9. And that answer now matches what I started my whole division problem with. This is good news. That means that this answer that we had here, the whole thing, even including that remainder, that was indeed the correct answer to this division problem that we did. So I wish you the best of luck when you're doing your long division.